Okay, let's resume. I just copy and paste this website to you. I just search it. Because the Google spreadsheet has no this kind of function, and I search the box plot online application. I got this website. I just copy and paste it to you. Okay. Well, for example, if I select number here, copy, and to this online application, I post the number that is here, then go to next label. No, I don't need label, and display. Here is the answer. Here is the answer. I try to find some open source applications. Then you can select, for example, the life expectancy. Just it means the average of the life from 11 countries. And here the minimum 64, the maximum 77. The Q2, the median of those 11 countries is here. The Q1 and the Q3. Get it? Then you can make a copy, take a screenshot of this, and paste to your website. Okay. And so far, any question about the chapter 3.3? If not, we can move to next section. Okay, then. Okay, the same. 11 numbers, and the median is the center one. Just one member located on the center, so it's very easy to calculate. And this part, 1, 2, 3, 4, 5. The second part, 1, 2, 3, 4, 5. The first 5 members here, we can find the center one. 65 is the Q1. And this part, let me draw it. $64 is here. 68 is here. Okay, then 77 is here. Then that is easy to find Q1 and Q3. Q1 and Q3. Thus the Q3 74 minus Q1, that is 65. Thus IQR is 9. And here's the diagram. And the number here is a little bit larger than. I may not ask you to run this example. Maybe few number is easy to understand the concept. Okay, let's move forward. Okay. And the software I will give you, that website, you can use it. And it's okay. So how about finish this part? Let's move to next chapter, number 4, probability. Okay. Probability, there are 4 sections. The first one, empirical probability, it means during the experience. The second one, theoretical probability, sometimes it's very difficult to get the empirical or to do the exams, to do the experiments. So theoretical probability is important, and conditional probability and counting techniques. Let's move to the first one. And this part is a little bit easy, and I will explain very quick. Okay. Okay. Let me have a brief introduction of this part. Empirical probability. One story about how probability theory was developed is that gambler gambling is a kind of gambler wanted to know when to bet more and when to bet less. He talked to a couple of friends of his that happened to be mathematicians. Their names are Pierre de Format. So I don't know how to read the French. Okay, and this person, since many other mathematicians have worked to develop probability theory, understanding probability are important in life. Examples of mundane questions that probability can answer for you are if you need to carry out an umbrella on a weather or a heavy coat on that day. This okay. Let's move forward. Okay, here the first definition: experiment. Experiment, an activity that has specific results that can occur, but it is unknown which results will come. For example, my master research and my PhD research, we did a lot of experiments about microbiology. And the second term is outcomes. The results of an experiment. Event, a set of certain outcomes of an experiment that you want to have happen. Okay. Then sample space, collection of all possible outcomes of the experiment, usually denoted as double S, capital, SS or double S. And event space, the set of outcomes that makes up an event. The symbol is usually a capital letter. Okay. Then, start with the experiment. Suppose that the experiment is rolling a dice. Dice? We call it dice. Maybe dice is better. Okay. And the sample space is 1, 2, 3, 4, 5, 6. The dice is that the event that you want to get a 6, and the event space is 6. To do this, roll a dice 10 times. When you do that, you will get 6 for 2 times. Based on this experiment, the probability of getting a 6 is 2 out of 10, or 1/5. To get more accuracy, to repeat the experiment more times. If it is easiest to put this in a table, when the n represents the number of time of experiment is repeated. When you put the number of sixths, found over the number of the time you repeat the experiment. This is the relative frequency. Take a look at this table. If we throw the dice for 10 times and it came twice of the 6, and 2 divided by 10, that is 0.2. It's called a relative frequency. And if I throw a dice to 50 times, to sum up 6 times to come in for the point of 6, and the relative frequency is 0.12. If I have chance to do an experiment, I throw 1,000 times of the dice, and I got the number of 6 is 163. The frequency is 0.163. Okay, let me have a. Let me have this. Roll a dice. Okay, I think if I set the number is here, I think it's a simulation from the software. I click for 10 times. Okay, I get how many times of 6 on the screen? 1, 2, 1, 2. I click for 10 times, and sure I can set a simulation by the programming. Then I can do the experiment by the computer to throw it for my maybe 1,000 or 1,000,000 times or 1,000,000,000 times, and show the probability to come of 6. Okay. Then come back to our textbook. Okay. Then here experimental probability, the function name P means the function name of P means the probability, and A is the number of times when A occurs, and the denominator that is number of times the experiment was repeated. For example, I click. Maybe how about this one? Here is a website. Okay, maybe I copy and paste this website to you. Okay, assume I wrote for 10 times and options. Okay, go. I showed and start. Stop and go. So what's the result? Oh, okay. Sorry, it has no summary of this. Maybe I can skip this. Again, let me do it again. Okay, if I wrote for 10 times, 1, 2, 3, 5, 6, 7, 8, 9, 10. And this time I rolled the dice for 10 times and I got 3 times of 6. 3 times of 6. So this different experiment. But $1 you just roll it for 10 times and you got 2 times. Why this time is 3 times? Because the background is a simulation from the computer program language. And this time I click it for 10 times. And there are 3 times of 6. There are 3 times of 6. It's experiment. An experiment. Okay, get it? An experiment. So I just wrote the total number. I rolled 10 times on the dice, and I get, for example, the number 6. I got 3 times. Thus, 10 times. Yeah, 10 times, and 3 are 6 points. Thus, the probability is 0.3. Okay. And here, the definition, law of large numbers. As n increases, the relative frequency tends towards the actual probability value. When the number maybe 10 times, 100 times, 1,000 times, 10,000 times, when the throwing number is increasing, the relative frequency tends towards the actual probability value. And note, here's a note. Probability, relative frequency, percentage, and proportion are different words for the same concept. Also, probability can be given as percentages in the kind of format, or in decimals, or in fractions. It's up to you. Okay, here is the homework. Exercise 4.1.1. Example 4.1.2 contains the number of M and N, the kind of food. Each color was found in a case. Find the probability to choosing each color based on this experiment. And the M&M, the chocolate, the blue, 481, brown, 371, green, 483, orange, 544, red, 372, yellow, 369, and the total number is 26 and 20. That is experiment. That is an experiment. Okay. And the second example, eyeglasses somatic manufactures eyeglasses for different retailers. They set to see how many defective lenses they made the time period of from January 1st to March 31st. And example 4.1.3 gives the detected and the number of defects. Find the probability of each defect type based on this data. There are different defects: scratch, right-shaped small, flat, wrong axis. I think this one is the worst one. Chamfer wrong. I have no idea about this. Crazy cracks, big cracks, and wrong shape. Here is the defect number. Okay. And let's move to next. Okay, here is the 4.1. Let's move to next. And 4.2, that is a little bit harder because it's probability during the experiment. Okay, let me copy and paste this to our Line group. Okay, then the next section is theoretical probability. It's not always feasible, it's not easy to conduct an experiment over and over again, so it would be better to be able to find some probabilities without conducting the experiment, and the probability are called theoretical probability. To be able to do a theoretical probability, there is an assumption that you need to consider. It is that all of the outcomes in the sample space need to be equally likely outcomes. And this means that every outcome of the experiment needs to have the same chance of happening. Okay, example 4.2.1, equally likely outcomes. Which of the following experiments have equally likely outcomes? First, rolling a fair dice. Flip a coin that is weighted so one side comes up more often than the other side. Absolutely, this is not. This is wrong. In the US, the cross we call the check, but in Taiwan, the cross we call it wrong. It's different concept. And rolling a fair dice, that is correct. C, pour a ball out of a can contains 6 red balls and add green balls. All balls are the same size and also the same texture of the surface. Okay, I think it's okay. Pick up a card from a desk. Okay, then roll a dice to see if it is a fair. You can check it. Okay, then move to next. Okay, now the definition, theoretical probability, very similar to previous definition. If the outcome of an experiment are equally likely, then the probability of event A happening is probability of A. The numerator is the outcome of event space, and the denominator, that is outcomes in sample space. Event space and sample space. What's the difference? Denominator, that is sample space. It means all probability, all possible outcomes that exist in the event. Event is what you expect. For example, I have a dice. There are 6 squares on the dice, and I expect the dice with a 6. That is the event. Okay, then example. Calculated a theoretical probability. Suppose you conduct an experiment where you flip a fair coin twice. Okay, a coin twice. What is the sample space? If I have a coin, the one side is $10, the other side is Jiang Kai-shek, Chiang, Jiang Kai-shek. Actually, my family name is Jiang, the same spelling as the Jiang Kai-shek, the former president in Taiwan. Okay, so what is the sample space? One side is $10, the other side is the former president. And okay, the question number 2, What is the probability of getting exact one head? Exact one head probability, the sample space is 1, 2 in the denominator. Probability of head, that is 1, the sample space is 2, so this one is 2. What is the probability of getting at least one head? At least one, it means one, the first time one head, the second one head, or the first one head, the second is $10. The $10, okay. Let's see what's the probability of getting a head or a tail. Getting a head and a tail, okay. Then what's the probability of getting a head or a tail? What is getting a foot? Okay, what is the probability of each outcome? Where and what is the sum of those probability? Okay, and let's check the textbook. The sample space, head, tail, head, and tail. So the sample space is 4. Okay, let the event get exact one head, and the space is A equals head, tail, and head. So the probability is 2 divided by 4. That is a half. That's a half. It may not have advantages to reduce the refraction to lowest terms, since it is easier to compare fractions if you have the same denominator. Let B getting at least one head. At least one head means getting one or more. The space event is head, tail, head, head, and the probability is 3/4. Since probability of B is greater than the probability of A, then the event B is more likely to happen than event A. Then the question D, let C getting a head and a tail. The sample is head and tail and head. Then the probability is 2/4. And okay, let me very similar. Let me skip this one. We can do some examples. And properties. First, probability of any event will be larger or equal to 0, but they will be smaller or equal to 1. I think this concept is easy but important. The probability is larger or equal to 0. The probability is less than 1, less than or equals to 1. Sorry. Okay. If the event is 1, it means it will happen. It's called a certain event. If the probability is 1, in our language, I 100% guarantee it will happen. Okay, so that is a certain event. Then the second one, if the percentage, the probability is 0, then it could not happen. It's called impossible event. One thing is very close to the impossible event. Tonight, I will go to a lottery store and buy a lottery. The probability I get the largest prize, the probability very close to 0. But I will never give up. Okay, that is called impossible event. And sigma to sum all probability of the outcomes, that will be 1. Okay. And here, Suppose you conduct an experiment when you pull a card from a standard desk. So, what is sample space? What is the probability to get a spade? We know there is a spade, diamond, club, and heart. Four kind of patterns. Thus, what probability to get a spade should be 1/4. Okay, we just do this, and we can check it. The sample number, the order on the textbook, this is 52 numbers here, and let A, the event to get a spade, and there are 13 events here. And the total sample number is 52. So the answer is 13 over 52. Okay, then let's move to next. I think this part is not hard for you because most of you already learned this from high school. And this one is okay. Okay, let's move to the definition. 4.2.2 complementary events. If two events are called complementary, then to find the probability of one, just subtract the probability from the other one. Notation used to complete A is not A or A and this C. Complementary. There is 1, and the probability is 1 minus probability of A to the C. Okay, for example, suppose you know the probability it raining today is 0.45. What is the probability of it is not raining? Okay, today the probability of raining is 0.45. How about not raining? The total probability is 1, subtract the other one, and get 0.55. Like this one. And the second question, suppose you know the probability of not getting a flu. Is 0.4. So what is the probability to getting a influenza? 1 minus 0.24. That is 0.76 of this. Okay, get it? Let's move to next. Here's the answer. Okay, the answer. Okay, let's look at the example 4.2.6. Using the complement to find probability in an experiment of roll a fair dice on time, find the probability of rolling at most at 4 on the dice. Okay. The solution, the sample space of this experiment is 1, 2, 3, 4, 5, 6. There are 6 probabilities, 6 possible situations on this. You want the event to getting the most is 4, which is the same as thinking getting 4 or less. The event space is 1, 2, 3, 4. Thus, the probability is 4 over 6. 4 over 6 because you defined at most at 4. At most at 4. That is 1, 2, 3, 4. 1, 2, 3, 4. Thus, get this kind of condition, the probability is 4 over 6. The second question, in an experiment of pulling a card from a fair deck, find the probability of pulling at least 5 S is highest card in this example. S is not a number one, it's the highest. Okay, then we can check this. There are 52 cars here. 52 cars here, and the question is, you want to get the event getting here at least a 5, but S is the highest car, though thus that will be exclusion. Let's be inclusion, not counting it. Thus that will be 2, 3, 4 space 2 club, 3 club, 4 club, 2 diamond, 3 diamond, 4 diamond, 2 heart, 3 heart, and 4 heart. Thus, there are 12 possibilities, so 12 combination here, and the denominator is 52 cards. Thus 1 minus 12 over 52, that is 40. That is 40. Okay, get it? Let's move. Oh, okay, I think this part is very similar. I will skip this one. And let's look at the definition here. Definition 4.2.3. The actual odds against. It means against. Event A occurs are the ratio of probability A to the C divided by probability of A, usually expressed in the form of A to B, or read as A to B, where A and B are integers, not decimals, integers, okay, with no common factors. And the second definition, actual odds in favor. Event A occurring are the ratio probability of A over probability of A complementary, which is the reciprocal of odd against. If the odd number against the event A are A to B, and the odds in favor the reverse side, that is B to A. That's B to A. Very similar because it's reciprocal. Reciprocal, for example, 1 over 2. Reciprocal is 2 over 1. 4 over 7. The reciprocal is 7 over 4. Okay, reciprocal. Okay, the definition number 4.2.3. The pair of odds against the event occurring are the ratio, that is net profit, if you win the amount of bet. Pair of odds against the event, that is net profit to amount bet, And let's move on. Okay, I think we don't have enough time. We can finish the first example here. Okay, the example 4.2.8. Odds against and pair of odds. In the game of craps, if the shooter has a come out roll of 7 or an 11, that is called the natural, and the pass line wins. The pair of odds will give the casino as 1 to 1. Question A. Find the probability of a nature. Okay. A nature is 7 or 11. The sample space. There are 36 combinations because you have two dice. And each dice has 6 square with 6 points, and 6 times 6, that will be 36 events. That is a simple space. And now the nature is 7 or 11. that will be 1 plus 6, 2 plus 5, 3 plus 4, the same one. In total, there are 8. There are 8 combinations to get 7 or 11. So find the probability of a nature that is 8 divided by 36. And the second question. Find the actual odds for a nature. Out of a nature, the probability of 7 or 11, and the probability not 7 or not 11. So the first, the numerator is 8 divided by 6, and the denominator 1 subtract the numerator. Thus, that will be 2 over 7. And question C. Find the actual odds against a nature. Okay, according to the definition. The definition, odds against a nature, probability not 7, not 11. Probability of 7 of 11, that is 28 over 8. 28 over 8, that is 3.5 over 1. Okay, the next question. If the casino pays 1-to-1, how much profit does the casino make on a $10 bet? Oh, it's good. According to the definition, the actual odds is 3.5-to-1, while the payoff odds is 1-to-1. The casino pays you $10 for your $10 bet. If the casino paid you actual odds, they will pay 3.5 over every $1 bet, and that is $10. Thus, that will be 10 times. It will be $35. The profit is $35 minus 10. That's your bet, and that's 25. That is 25. So, is it okay? I think this part I will give you a little bit of example similar to the textbook. Okay, I think we can stop here. Just 2 minutes to have a break. Then any question? Okay, so next Friday, we may start from the second class. I think you can finish the exam very quick. So if no more question, then stop here. Then see you next week, the first exam. Okay, see you everybody. See you next time.